Great. Well, it is so wonderful to see so many people from especially coming to the room here, but also online. We really appreciate having everybody. We'd love to hear, and I certainly would like to get to know during the day. Let me grab this so I can walk away a little bit, where everybody's coming from. You can see we have representations from many different people across the industry. We have people who are building hardware, we have people who are building models, we have people who are building software. Really excited to see the broad community, which is what we're actually looking to do here. So that's really excited to see so many broad people participating on our first major event that we're having. I think we already went over these slides, so thank you, Marissa. We'll flick over through, but we'll now move on to what I actually was up here to talk to you about, which is a little bit about what we're doing with this project in the first place, why we kicked it off, what we're looking to achieve. My name is Andrew Lever, and I'm responsible for managing one of the machine learning compiler groups here at Google. And we deal with many challenges, and I'm sure we're not the only ones. We hear from a lot of our users around this. There was a time when you could train your model on a GPU and a server underneath your desk, and you could run it on an inference on any arbitrary server that's out there with a CPU. That isn't the case anymore, hasn't been for a number of years, and we don't expect that to change. So models, as we all know from generative AI, have gotten enormous with billions of parameters, training for months on potentially thousands or tens of thousands of accelerators. They keep changing, so it's not enough to just get one model optimized and get it working well. If you do that, there's another one that comes along in a few months' time. And this doesn't stay static. So every 3 to 6 months, there's a bigger model to train. There is an increase in cost. We see that overall, more and more, it's gone that people have to think about what they're actually spending to be able to both train and run inference on these models. And that's something which has really dramatically changed in the last several years. And the challenge that we all have is there isn't just one way of doing these things. It's not you write your model once and off you go. There are multiple frameworks which are in broad use. So we have an enormous number of users on TensorFlow. We have an enormous number of users on PyTorch. There are other frameworks such as JAX that are being used today. That's not going to change anytime in the near future. Much of the software we end up using is software which is new, which is maybe developed comparatively quickly to solve short-term problems. I think a great example here is Triton that many of us rely on, but which was a comparatively rapidly developed piece of software, which is still needing a lot of evolution to get it to be a fully polished product. As we see, that's typical. It's true of all software across the industry. And of course, there's many different ML accelerators. We come up with new ones every year or two, and we have many different companies trying different alternatives. So if you look at all of this, as a machine learning practitioner of any sort, trying to deal with the models, complexity and change, the hardware that's coming up, all the new software is being developed, it is really not easy. It's a constant challenge to get anything to work. Which leads us to the opportunity that we have. So we would like to be finding a solution here which enables us to build a software stack that addresses all of those challenges we just talked about. So we clearly need to be powering all the most key current models today and being prepared for what's out there in the future. We need to be able to support a broad variety of use cases. It's not enough to specialize for LLMs these days. You need to specialize for a stable diffusion. You need to still be able to support all the other machine learning which is out there and has been used for many, many years and will continue to be. There are applications from large-scale training all through inference, lightweight or more heavyweight, and we have data center and edge use cases as well. So we think that we know some of the ideas here at Google about how to solve these problems, but we only have that tiny piece of the picture on it. I mean, it was great to see so many names on the slide just a minute or two ago. We know that no one of us has the information to be able to solve this problem on our own. We need the model practitioners. We need the framework developers. We need the hardware manufacturers. We need the software infrastructure folks. So this is why we need a community. We'd like to bring all of you in to bring your insights and to be able to help us solve these challenges together. So with that, I'd like to bring up Stella to go talk about vision for how we're going to achieve this.
Quick question. How do I change the slide?
Just the down arrow key.
Okay, perfect. And as Andrew said, it's great to see everyone here. I think that, you know, I've run across a lot of you, and it's great to connect faces to names, it might have been a little bit easier to write Discord IDs or GitHub handles on your badges, because I live in a sea of random handles. But it's really been great as especially coming out of the pandemic, and a project that really pivoted and picked up steam over the last few years. I was reflecting that any other time I've done this in my career, I would have met everyone face to face many times over by now, and it's really great that we're getting back into the habit of actually putting the people together and making the connections, because that's really what makes all of this work. So I'm going to talk a little bit about where we're trying to take OpenXLA and get it moving in a direction that's community powered and whatnot. I was honestly expecting that this would show my speaker notes, so sorry about that. But the vision we've got, as Andrew alluded to, is that we really want to create an industry standard solution set here, a toolkit that we can all apply to take machine learning compilation forward. We want it to be developer powered, developer accessible, integrator accessible. When we talk about this, there's the north side frameworks, the south side hardware makers, and then there's the compiler infrastructure in the middle that brings it all together, and that's where OpenXLA really sits and wants to bring those ends together and help them co-evolve. We need it to be open, and I think this is something that as Google, we've been doing open source for a long time. It's a lot of it is we publish and people subscribe. We're really trying to do this differently. We're trying to establish this as a community watering hole that with norms and governance that we can all partake in. And we want you to hold us accountable to that. This is just for full disclosure, something that we're learning as we go, and would like to evolve on. And then finally, probably the most important one is that we're all here because of performance. We're all here because we're either building or exploiting silicon. I think we're all exploiting silicon. I don't know if we're doing post-silicon stuff here, but we're all exploiting silicon that costs a lot. That it costs a lot to develop. It costs a lot to deploy. It costs a lot to keep running. It costs a lot to target, and we need to be able to get everything we can out of it. And that's going to create some interesting co-opetition that goes on. But we're all here for the performance. We're all here for the numbers. We're all here to be able to leverage our investments in a timely fashion. So as I alluded to, we're unlocking. We're looking to unlock some of this pent-up energy that's been distributed throughout the ecosystem. Create a community watering hole, and we're doing that in this ecosystem through compilers and what they connect to. A lot of this stuff comes out of both the shared lineage of XLA and MLIR, which have both been pretty prominent on many stages over the last decade, and we're looking to bring that together to pull everyone in and uplift that. So as we phrase this, we think that this is a positive sum outcome. I'm pretty big on things that create the best chance for a lot of us to win, and I think that in order to do that, as we've said, we're really investing in open source first. This is moving our development efforts to the public side of the fence, making Google a stakeholder that's subscribing to the technology just like everyone is, and really using it in the way it's being developed. We're trying to create a composable ecosystem of tools. Like I said, this is not a traditional compilers are not a traditional software development enterprise. We exist in a stack of middleware that reaches up to the users, and it's important that we have navigable routes from the users through the tools they use to the compilers, to the hardware, and us being able to put the pieces together, assemble that quickly, be agile, move, is what makes us successful in reaching our goals. And finally, the thing that goes with open source first is we are really working on moving to a governance model that gives everyone who comes in a stake. If you're contributing, if you're a technical stakeholder on this, if you're putting part of your business into it, we want you to get that back out. This isn't a one-way street. And some of the stuff is aspirational. I think it's important to call out that it's aspirational, but this is where we want to go. So what is OpenXLA? OpenXLA is basically, like I said, drawing from the lineage of XLA and MLIR, and connecting these north and south side touch points, the incoming frameworks, the hardware ecosystem, through compiler technology. And one of the things one of the themes we're doing, as opposed to just like creating a watering hole that we're putting out everything in, is where we can, we're trying to establish APIs that normalize things as we go. So you'll see that throughout the day and throughout the presentations. This space has been somewhat fragmentary for a long time, and that's not, we're not alone here trying to set that right, but we're trying to do our part and leaving APIs and accessible connection points where we go. So you'll see more about that. We're focusing on production grade connections. We're focusing on production grade interop points. We're focusing on things that we're building our own business on at Google, and that we're hopeful that others can as well. And then the last component that we're bringing in is benchmarking infrastructure and documentation. This is the shared burden that we all have, right? Like, we've all been in this business for a long time and build this stuff vertically, and step one of every project is go get the thing to run and find the baseline numbers and do the comparables with the other tools, which then never work, and you waste months even just trying to get a number. So we think that as we go, APIs, composing through tools, production grade interfaces, and tooling is really gonna help us achieve some more velocity in this industry. To that end, what we're going to be talking about more today is the stable HLO offset, and the work that's being done to put more of an API at the program representation level for popular ML frameworks. We're going to be talking about the compiler assets that are coming into the OpenXLA ecosystem, both from the XLA and the MLIR lineage, and we're going to be talking about PGRT, which our friends at ARM happily named the pajama runtime for us, which has unfortunately stuck a little bit. So this originally was pretty much just another runtime, was the acronym, but now everyone seems to call it the pajama runtime. So thanks to the ARM folks for that one. And that's really what we're using to compose this together for JIT serving cases with the frameworks, and we'll be talking more about that as well. So I'm going to breeze through some of these slides because they're really just an intro to what's coming as part of the future presentations in today and beyond. But let you read here. These are real projects that exist. Stable HLO has been evolving for the last year or so, built on the last 10 years of evolution of the XLA upset, and is approaching its 1.0 version, targeting a test suite, reference implementations, and is looking towards additional functionality, dynamism, quantization, sparsity, etc. I believe Eugene will have some more to say about this shortly, and the GitHub project is listed. The compilers that we're investing in, like I said, are coming from multiple directions. What we're contributing to the OpenXLA project and is the existing XLA compiler toolkit for CPUs and GPUs, and what we started to bring in December is Erie. If you're not aware of it, this comes more from the MLIR lineage of compilers, and we're bringing these together pulling them together to run Google's production workloads on the platforms that we're targeting here. I've also listed a couple of other new entrant projects that have been developed open source first from the get-go, with RFCs sourced from the community. Both the NVIDIA GPU specializations for the OpenXLA compiler built on Erie, and the PGRT plugin, where we're building the plugin as the plugin to the frameworks is a modular piece of code that is separable and adaptable. And then, the last piece of the layer cake here, the PGRT, is what we're emerging to bring together the interface to TensorFlow, PyTorch, and JAX for JIT serving cases. There are other cases it serves, but this is what it's focusing on to start with. This stack of APIs is where we're concentrating distribution support for horizontal scaling, interfaces to the compiler, APIs up and down, and where we'll be targeting a number of test suites and tooling to move this thing forward. And this is this component has existed for quite some time in JAX and is being modularized and developed more independently. You can see the RFC that talks about taking this forward, and I believe that Aman will be having a presentation more on this later today. So, if you all were wondering why everything we have is named XLA, it's we had 3 letters to choose from, I guess. I'm not going to claim that naming is not a hard problem here, and would beg some forgiveness. Basically, what we're trying to do is we're trying to evolve the ecosystem from the existing XLA compiler and infrastructure to the OpenXLA compiler. We're passing that through and re-open sourcing the components as we go. We're building them in the community, and we're trying to infuse them with both the MLIR and the XLA lineage as we go. So you're going to see a transition over the next 18 months as we start to invest more in what we're calling the OpenXLA compiler, which is combining both Erie and XLA. We are open to feedback on this as it evolves. We know that things that change can be hard. We're not leaving anyone behind, but we are evolving our stake here and pushing this direction. Speaking of the timeline, the transition to the OpenXLA stack of components has started this year. It will proceed through this year and into next year. This is coupled with projects on the Google side where we are eating our own dog food on this, and we aren't just pushing a big switch change, but we're focusing on the top line workloads and starting to productionize the technology for use and internally. And the reason why I think that is important is this is all about production. This is all about performance. This is all about getting the capabilities launched for everyone. And I think it's important for this community to see that we're developing this for some very top line needs. And finally, I'll close it here with some resources and just invite you to enjoy the day, enjoy the connections. Hopefully you learn something, and hopefully more than that, we get to meet some people we haven't met before and carry that forward. So thank you very much.
So yeah, I was going to say, don't go too far away, Stella, because hopefully you can help out here as well. We had a few items that we wanted to talk about at the end of this, which is sort of some of the obvious, like, why now, how things would be either the same or different from the future. We'd love to hear more questions that everybody has as well. So this is just a few initial that we were starting with. So one of the first ones here is that, how do we know Google's committed to this project? So we wanted to make it clear that what we're doing here is our own production infrastructure, right? So we're not building things for the sake of building things. None of this is developed because it seemed like a great thing to do, or that it was, you know, something where we're doing it because it's an interesting toy project or a piece of research. Code that's today in OpenXLA is being used internally. So a good example would be stable HLO, where is actively consumed and used inside here at Google, and that should apply to all of the areas that at least Google is contributing here. Given that this is going to be a community project, maybe there'll be pieces that will come in future which we won't use, but that would be great, and so on, as if we develop more widely. But we're absolutely committed to working on this. Secondly is, well, what about project communication? So, you know, I think that it's very easy to have an open source project where the code is all out there, and that it's still kind of hard to actually know what's going on a day-to-day basis, where roadmaps are, where, you know, why decisions were taken and so on, why technical decisions in particular were taken. So we hope that today actually at least starts out here, where we see the reason for hosting an event like this and when bringing so many people in is exactly to start with a level of communication that we think is needed on this project. And hopefully a good number of you have been involved in our monthly community meetings, and that you're seeing there that we have openness and transparency. It's our commitment here to be developing in the open, because we believe earlier on, as I started out with, that's the only way as a community we're going to succeed in getting everything, all the pieces of expertise we need together to end up making this a true stack, which is actually meeting all the needs that we have and that the rest of the community has as well. And then this last one is, you know, how do we actually make sure that this isn't a one vendor such as Google's project? I think on that one, I highly encourage everybody to look at the governance discussions that we're having. We are in the early stages of that today. We have, as Stella went over, a commitment here to be able to bring people from outside of Google anywhere who's contributing to the project to make to take a leadership role in the project. That's the absolute intention. We're modeling the governance that we have with success that we've seen in places such as LLVM and PyTorch, who's recently been involved in governance for their standards. This is something which we all have to work on together as a community, and obviously there's no way that one team can stand up here and go say, we know this is all going to work great, but this is a really important piece for us that we think is going to be necessary for success. And I would invite Stella for you to add some comments as well.
Well, you covered that pretty comprehensively. I think I would just plus one pretty much what you said. I think that the governance talk, there is a talk that Taya will be giving later today, just highlighting this because I know that people have been asking, and encourage you to join in on that. And if you have experience and thoughts about this, please participate. Like I mentioned, this is bootstrapping a community like this is not something we do every day, and you're not exactly born with this skill. So hopefully this is a community of friends that can get this going. Were we going to open this up to questions?
Yeah, sure.
So we can open it up to questions from the room.
We can take live questions, and I'm also going to present that Menti I mentioned to y'all, where you can log in and ask questions right into the Menti. Here you go.
This is new to me. I haven't seen that.
I had to get a little creative for this group. So if you head to Menti and type in this code, you'll get an open Q&A format. Alternatively, I can come to you with a mic.
Hey, you are signaling wildly. Do you just want to say something?
Oh, of course. If you're online dialed in, this also applies for you as well. You can ask a question directly in here.
This is E from Apple. Slide the deck, it presents PGRT and all the great ideas for distributed training. My question is, will on-device inference and training still be an interest of this project?
Yeah, so unqualified, yes. I think that that the investment priorities at at Google on that. This is not our top line priority for this year, in terms of pushing the compiler stack to on-device training in this way. But we are leveraging these components in our stack. What I'd point to is that getting the compiler and the infrastructure good for mobile and edge is largely about getting the infrastructure, getting the API connections on the program representation, having good AOT, and having good platform support, and that is directly in line with the community ethos. We've tried to focus on what our top line business priorities are as when we're signaling what we're investing in, and it's a mobile and edge is incredibly important, but it's also incredibly diversified. This is where we need to source from the community. This is where we need to make the owners of the platforms really have a spot in the ecosystem and able to push. And this is where we need to get early support from our APIs to make sure that they're targeting these deployment form factors and not just working in a JIT case. So definitely important. And you'll probably hear less about that because you may have noticed that training LLMs is eating the world, but it's important, and we invite everyone in to help with that, and we'll be doing a lot of things behind the scenes as well.
I just want to add that from the community, this is Anush, CEO of Nod, and just want to add to your point that we do have training on device and mobile also, but we work with the ED team, and the ED team has been supportive, even though that may not be their top priorities. Like, there are priorities for us that we have to support training all the way down onto mobile phones and desktop GPUs, some of which we've announced, some are in the process. And I just want to say that the community involvement covers that piece, even though Google may not necessarily have that as a priority.
Yeah, we're a strong friend on this. We absolutely want the platform to generalize to these things, and we want the APIs to work well for AOT and deployment cases that are common.
If there's perhaps one just thing I could add as well, which is stable HLO in particular, that we actually see one of the challenges which we didn't talk about here today was alignment between server and mobile ecosystem. So we find it very easy to develop new models on server. We find it hard to port them to mobile. We'd love to improve that, and stable HLO is actually one of our initiatives that we're looking at in that area. So I encourage you to talk to some of the folks here about that today.
Sure, definitely. Thank you very much. And shark is a good word.
Yeah, we all benefit from having fewer stacks here, from having fewer ways from the user that are high quality and more in common, and that's really what we want to be skating towards. In the back.
So I'm from Iowa as well. So
Thanks. I'm from Apple as well, and as you know, I think Apple would like to keep some of their stuff closed source.
Yep.
So will OpenXLA be like discouraging this kind of usage, or like if we all still want to leverage OpenXLA, what should be the strategy?
So I think that there's multiple ways to think about that, and first of all, I don't think that that's a single. You're alone in that situation. You know, everyone has boundaries that they want to maintain in this ecosystem. Our goal is to increase the size of the commons, but not make it exclusively common. So some of the stuff that you'll see that we've done recently on this is produced and there's an RFC that we can point to. I can point to offline, but it created it both compiler and runtime plugin models for allowing out of tree specialization for specific slices of the stack. I expect that this is the beginning of this story. You know, so of course you're free to maintain a forking strategy or a branching strategy as you see fit, but what we're trying to do from the platform standpoint is make sure that there's plug-in points that make sense at a couple of different levels that don't require you to fork completely at the top level in order to have a private or time to market sensitive development. So it's a bit of a negotiation, but it's one that we've engaged in fruitfully multiple times and want to create more API surface area for better connections. Obviously, open source is great until it's not, and we want to support those use cases too.
Okay, thank you. And one related question is, so like Apple invest a lot on device machine learning,
Yep.
and binary size is a pretty big concern of this. And do you have some plan to make it composable and we can just?
Yeah, so you'll notice that one of the projects that we're pulling into the OpenXLA umbrella is Erie, and this was a mantra of ours when we wrote that. It was basically how do we slim this down? How do we make sure that it's not just slimmed down once, but that it's slimmed down forever? And that's our contribution to this space, basically showing that we can do that. We can focus on binary size, and we do obsess about that. I have observed that is, it's important to take in all the requirements from the ecosystem on this stuff, and especially for training side implementations and server side implementations. The just slim it down approach is doesn't work for mobile and embedded. So that's really why we started Erie the way it was. You've got to have these controls in place from the beginning, or else it's not going to work. And the binary size of the redistributables is one part of it. The other part of it is the compilation strategies. We know that it may be appropriate to do massive amounts of unrolling for certain architectures and produce very large compiled binaries, while for other architectures, particularly on the edge, oftentimes the balance is different, and you want something that's more size optimal. Internally at Google, as part of developing Erie, we've explored both of those fronts, and I think that's both of those specializations are important. It's really important to have these voices in the community and pushing that agenda, and it's welcome.
Thank you very much.
Yep.
I think just one thing to add, like binary size is actually one thing we constantly tracking in Erie Protect. So we'll make sure that is actually always one of the concerns we take care of.
You next to each other.
Hi, this is Raghu from Sampanova. So this one high-level question is, I think in your diagram, one of the things was with OpenXLA is the framework independence. This JAX, TensorFlow, PyTorch. I guess the hard part is there's a clash of communities here.
Yes.
PyTorch has its own community, and OpenXLA is, of course, now we're all here. So philosophically, if someone is maintaining framework parity such that we support all of PyTorch and all of TensorFlow, what's the view on who handles the burden? Basically, it seems like a decent chunk of work.
Yep.
Semantics are not exactly the same. So
Yeah,
what's the view so far?
Who's normalizing that? So first off, there is a session this afternoon specifically on PyTorch. I'd encourage you to join. Shaheen, I believe, will be chairing that, and I think that there's some answers to that will be a little bit more elaborated on, that needs work and needs help. But we completely agree. We have to have that framework optionality for our business too, and that's an incredibly important shared component to get right. So in getting slightly below the easy answers, I don't think it's a clash of communities so much as communities that aren't keeping in view of each other. And part of creating some of this connective tissue, and part of the product surface for this, like TorchXLA being actually in the PyTorch Foundation, part of bridging the gap with Meta on these things. These are the things that are best done as a community with strong leadership, and that we are doing. And Shaheen will talk more about this. What we want to do is make sure that we're getting all the requirements in that everyone has, so that we're all shooting at the same target here. But I completely agree with you. Like the value of this stuff is basically what you get out, the positive sum outcome, and and not having to worry as much, or bear the complete burden of the framework connection is a key part of it.
Hi, I'm Mark, also from Samba Nova. And my question was about the internal development for the TPU and XLA team that's there. Are they also committed to using OpenXLA and staying upstream in terms of all the optimizations they develop, or is it going to stay kind of a separate project?
Like our friend from
I'm happy
Apple.
to take that if you like. Seeing as because this is actually a lot of the thing that concerns me on a day-to-day basis. Can you hear all right? It's nicer to be out here. Thank you, Stella. So we are developing a new compiler here with the OpenXLA compiler. This is, as I talked about earlier, a project which is intended to be one which is building infrastructure for Google. We have, just as we were talking about closed source earlier today, closed source for the TPU, and we use some of the code that is currently in OpenXLA, and we expect that to continue overall. Right. So what we're looking to here, as we've talked about building a new compiler, is to be seamlessly transitioning existing users. So, for example, we have internal users who use GPUs, for example, who use CPUs and use XLA as an accelerator there as well. We need to be moving those over to be using the OpenXLA compiler as well. So we'll continue to have some closed source code of our own. We'll continue to leverage the infrastructure here. That is one of the things that's very much on our mind as we're developing the new compiler.
Anyone else? Maybe last question.
Hey guys, Jason at AMD. So when we talk about the new OpenXLA compiler, and we're talking about IRI and legacy XLA. What does it look like in the future? Does it look more like IRI or does it look more like XLA? Are we? So I kind of think of there's overlap, right? There's AOT and JIT modes in both. Right. Are we grafting some pieces on one and onto the other, or are we building something up informed by both? Or and I'm asking, we want to know where to focus hardware support, right? For sure.
So where we're going is that we're investing heavily in the CPU and GPU backends for under IRI right now as part of the OpenXLA stack. We're also importing the optimization pipeline from XLA to be composed on top of that, specifically for horizontal distribution and high-level optimizations to start with. And we'll eventually be grafting those further together and not just a hard split. But that's the investment priorities we've got right now. We're not disinvesting in the existing XLA CPU and GPU stacks until it is appropriate to do so, and then that will be a long graceful community involved effort to decide what happens there. So hopefully, certainly from an integrator's perspective, we're aiming for, like it said on the slides, a light switch. This light switch thing, I think that the story is a little bit more complicated and case by case for basically where to spend your integration dollars on back end development. We should have that discussion in detail because it's going to vary based on everyone's risk tolerance and timeline tolerance, and we can help you parse that.
Okay, great, thanks.